In many previous videos, we discussed privacy with Carmela Troncoso, a professor of the SC School at EPFL. Today, we are going to discuss the big challenges of her line of work.
One challenge, technical challenge, is this thing that I said, decentralization of trust. We want to, the world for a very big while after the super peer-to-peer wave in the 80s moved to the centralized world in which the Googles and the Amazons of the world and the Facebooks have everything centralized. And as we said, this kind of bad from a privacy perspective, first because it's very hard to defend against somebody that has all the data, and second because it creates this asymmetry of power where this particular entity has now all of the data of everyone and can use it for many purposes. So the question is now how we can decentralize, how we can enable the same time of operations while not having any particular entity having all the data. And there are a lot of protocols that are invented to do these things that I call, for instance, multi-party computation, in which instead of giving the data to one entity and ask it to make a computation for you, you give, you split is kind of a metaphor, you split the data in two, you give the data to two parties, and these two parties interact to give you back the result, but none of these parties have actually learned anything. And this is what we call decentralization, which is when instead of using one particular party, we use several, that none of them by themselves can actually hurt your privacy, and they need to act all together to give privacy. So how to have more and more decentralization and how to actually make it work in the real world, because one of the nice things about centralization is that it's easier to secure. I only have one point there. It is easy to manage. While now when you have more, you're increasing network, you're increasing the opportunities of failure. So there are many challenges on how to decentralize and make it work in the real world.
Decentralization is one of the current major themes in computer science, and it clearly has major implications on privacy problems. Well, I'll let you guess now what the other current major topic of computer science is and how it affects privacy problems.
A second big challenge is machine learning. Machine learning has changed the rule of the game, like for most any other discipline that we have. And it has changed it in the sense that before we wanted to measure all of these privacies, all of these adversary probabilities, we would have to go equation hand by hand and measure all of these. Nowadays, you don't do this thing. You just take all the data, feed it to the machine learning algorithm, and the machine learning algorithm guesses for you. This means that building defenses against this very powerful black box is becoming very difficult. So a big challenge is how can we construct principal defenses that can beat this machine that, as we will know, can learn more and more and more, and is much better at extracting information, small pieces of information that we as humans were not able to actually model in a probabilistic way, but the machine can. How do we protect those? And also now it turns out that machine learning has the inverse problem, which how machine learning works is an algorithm. The algorithm on itself doesn't learn anything. You just give data to it, and then the algorithm absorbs this data and compresses it in what is called a model. And this model now encodes the data itself. So it has been discovered in the last years that now you can learn a lot of things about the data behind the model from the model itself, which on the one hand is a privacy problem for the people that put this data on the model. Like one thing that you can do is find out a particular face that was used to train a face recognition algorithm, and if this data set was associated to some maybe sensitive attributes, so like for instance there's faces of prisoners from a jail, you could learn this person was in jail. But it's also a very problematic business problem. Google spends a lot of time and a lot gathering our data and creating these models, and it's very bad for us, for them, if you can actually use the algorithm to learn their model or to learn something about their data, because that's their business secret. So there is another big, huge line of research about how do we protect the black box from attacks that try to extract information out of it.
Let's move on to the third and probably biggest challenge.
The third problem that is perhaps the most complicated because it's not technical, and as computer scientists we're kind of unequipped to find, is how then we transmit to the real world what are the privacy problems. All of these questions about the privacy metric you're asking me, how do we measure it, what does it mean, how does it translate to a risk, and how does it translate to consequences. And this, when you speak with a company, you actually talk about them about privacy technologies, and we may be able to do all of these wonderful things. They ask to you, but what is the gain? And how we translate all of our technical measurements to actually vocabulary that can be understood by even engineers that develop these systems, or the CEO of the company that's going to buy your product, is very hard. And also to the regular public that afterwards will consume the product and will demand this privacy. How do we translate attacks into risks? Both risks for the business and both risks for the privacy of the people. What are the consequences of these things? We don't have very good ways of explaining them. And we also lack in many ways metaphors to explain privacy technologies. Privacy technologies don't work like in the offline world. When you don't want people to talk to you, you build a wall and you speak in a lower voice. These privacy technologies, there is no wall. I just do some mathematical operation with my data, send it somewhere else that does more mathematical operation with the data, and the result can come out. And we do things that are actually not possible in the physical world, like this. I have two numbers, I just merge them, and the sum comes out without you ever seeing the numbers. We don't really have, like the example I give here normally is, imagine you have a vault where you put your number in, like a secure vault, like in the bank, and another one, and then the algorithm is kind of a Superman that's able to fuse them, and when you open, the thing that comes out is the sum. But of course, we cannot do this in reality. So how can I explain this to people? How can I explain this to my mother? What these kind of technologies do? And then it's much more difficult to make them arrive to the public because we don't have good ways to communicate them.
So the third big challenge is all about pedagogy. And you don't need to convince me that we need much better explanations of the moral issues posed by technology.
Yes, and including this idea of how do we actually, when we design privacy preserving systems, you design them in a very different way than what you actually learn in school. When we learn here at the university, you almost are always focused on functionality. I want to get this result faster with less data, and you never think about the privacy and security implications of this thing. The privacy engineer thinks in a very different way. The first thing that he thinks is, how can I get this result with less data and giving the minimal data possible to other entities? And then when you want to do this thing is when you require all of these magical technologies to do these magical things. But if you just think in the, I want to get the result faster and now, you will never even need the privacy technologies. So there is also a lot of work to be done on how to explain privacy engineering, how to train people to think in a different way than what the Facebook, the Googles, or the Amazons are thinking nowadays.
I think some of the main challenges are not just technical, but in this broader space of how does this connect to what we should be doing? How do we quantify fairness? How do we quantify the groups that we should be fair across? And I think one of the main interesting challenges is how can we do this in an automatic fashion?
But privacy is not only about that. The fact that we have private information allows us to create our own world, our own perception, and define ourselves and have freedom. And what I mean with this is that actually allowing people to know a lot about us creates an imbalance of power in